Hello, our dear students. In this session, we'll speak about with each other about the colored ions. What is the colored ions? Okay, in the first, we'll speak about the color in general. What is the color? The color is a mixture, or this light is a mixture of many colors. So, some something or some objects appear in front of us as black, as white, as green. So, how can the color formed? How can the color formed? So, there are three cases in general. The first case, if the substance absorbs all the spectrum color, so it appears black to the eye. The second case, if it does not absorb any color, so it appears white. So absorb all colors, appear black; absorb no color, appear white. So today we will speak about the colored ions. The colored ions, it is not black and not colorless or white. So we'll speak about the colored ions. So if the substance absorb a certain color, so it appears by the complementary color, which is the complementary color of the absorbed color. This complementary color is reflected to our eyes. So we see the reflected color, which is the complementary color of the absorbed color. So when the substance absorbed the green color, so it appears to us with the complementary color, which is the red color. So all colors fall here on this surface. Only if you notice that the green color does not reflect, so the mixture of the complementary color, which is reflected to our eyes, that we will see this object, and that is the color of this object. So we do not see the absorbed color, but we see the reflected color. Okay, the reflected color is the complementary color. All the complementary color or the reflected color is a complementary color to what is absorbed here. So what is reflected to our eyes? This is the whole bundle of light. Some of them absorbed and the other reflected. So we see the reflected, which is the complementary to our eyes. So there is a rule or a law. You can memorize it easily. Okay, it is called vi sorry vi boo vi here boo ger. So memorize it. It is vi boo ger. If the object absorbs violet, it appears yellow in the complementary color. This is the complementary color, and this is the absorbed color. This is the complementary color, and the other is the absorbed color. No problem. There is no arrangement for this. If the thing absorbed yellow, then it appears violet. If the substance absorbs orange color, it appears blue. If the substance absorb red color, so it appears green. So it is the complementary color that we see, as we have explained before. So how can we memorize it? Memorize it by vi boo ger. Absorbs red, appears green. Absorbs yellow, appears violet. Absorbs orange, appears blue, and vice versa. Okay, both are right. Okay, there is a rule here. When the complementary color unites with the color which complement it, the light color or the complete bundle of light is formed. So when any light is combined with its complementary color or light, the white light is formed. So here green red here, complementary colors to each other. So when they are unite together, they form light color or light, the whole light bundle. Okay, or the white light. Yellow and violet, here yellow, violet, they are complementary colors to each other, so when they are united they form white color. Here blue and orange, blue, B and O, if the blue color unites with its complementary color, which is orange, it forms white light. So this is a general speaking. We want here to speak about the ions, the colors of the ions, not the colors in general. So what is the relation between the color and the electronic configuration of the element or the ion? So here we have to notice something. Look at this. Scandium positive 3, scandium 22, 21. So 4s2 and 3d1, when it gives a positive, it loses 3 electrons, the 2 electrons from the 4s and 1 electron from the 3d. So in this case 3d is empty, 3d is empty, and the ion as a whole is colorless. Look at this. Zinc positive 2, 30, zinc 30. We have to memorize their electronic configuration. 4s2 and 3d10. And copper 29, 4s1 and 3d10. So copper positive 1 has its 3d completely filled with electrons, 3d10. Zinc positive 2, 3d10. So they appear colorless. So we have to put this into our consideration. If there is no electrons in the d sublevel, it appears colorless, like here in scandium. Okay, if the ion or the atom or the any ion in its oxidation state appears colorless, it means it is completely filled with electrons in the d sublevel, or the d sublevel does not contain any electron. Look with me here. Titanium positive 3, 3d contains one single electron. We know that titanium 22, 4s2 and 3d2, when it loses 3 electrons, so 2 electrons lost from 4s sublevel, and 1 electron from the d sublevel, so there remain 1 electron in the 3d. 1 electron means 1 single electron in the 3d, or 1 unpaired electron. So it is colored. Here it is not colorless. Red, violet. Vanadium positive 3, vanadium 23, 4s2 and 3d and 3d3. Okay, so when it is positive 3, it loses 2 electrons from the 4s and 1 electron from the 3d. So in this case there are 2 unpaired electrons. 2 unpaired electrons means here it is colored. So what is the relation between the color and the colorless in accordance with their electronic configuration? There is a rule, my friend. A rule states that when the ion or the atom of the main transition element has no electrons in the d sublevel, or completely filled electrons in the d sublevel, then it appears colorless. But here, when we speak about the colors, they are the elements or the atoms or the ions which contain in their electronic configuration unpaired electrons, like this vanadium 3d2, so it is blue. Okay, here chromium 3, and it is very important to memorize that chromium 3 is green. It contains only 3 electrons in the d sublevel, and it is green. So let's here see that when there is unpaired electron, this substance is described as colored and paramagnetic. Colored and paramagnetic is the substance which contain unpaired electron in the d sublevel. So the completely filled is diamagnetic and colorless. Here we have to calculate the oxidation state of each atom or ion, okay, and then calculate or make an electron distribution for this element or this ion, and know if it has if it has in its electronic configuration one at least unpaired electron in the 3D sublevel or the D sublevel, then it is colored and paramagnetic. When it is empty, no electrons in the D sublevel, or there is an electrons but they are completely filled, this D sublevel is completely filled in this atomic state or ionic state, so it is colorless and diamagnetic. So we have to memorize some very important elements. So here chromium 3 contains 3 electrons in the D sublevel and it is green. Manganese positive 3 is also D sublevel, contains 4 electrons, so it is violet. In general, when the D sublevel contains one unpaired electron at least, so it appears with color, it is not colorless, and it is a paramagnetic. When it is when it has no electrons in the D sublevel or contains D sublevel completely filled with electrons, so there is no unpaired electrons, so it is in this case colorless and diamagnetic. So as we see that chromium 3, it is green in color, zinc positive 2, copper positive 1, and scandium positive 3. Scandium 3D sublevel, empty from electrons. There is no electron in the D sublevel, so it is colorless. Its solution is colorless. Copper positive 1 for copper 29, its electron configuration 4s1 and 3d10. So if it loses one electron from the 4s, the 3d contains 10 electrons. There is no unpaired electron, so it is colorless. The same thing is the case of zinc positive 2 or the zinc atom, zinc 30. So its electron configuration is 4s2 and 3d10. So in this case, we find that zinc contains 10 electrons in the D sublevel, so it is colorless and it is a diamagnetic. Okay, let's have some examples here. Study the opposite figures. Describe the change in the color of each of the solution with the explanation after leaving 4 test tubes exposed to atmospheric air. So we leave these 4 test tubes to the atmospheric air. Ferrous or iron positive 2 will be oxidized into iron positive 3, so the color of the tube number 4 will be changed into yellow, as the ferric ion is more stable than ferrous ion, so it is easily oxidized by air into ferric sulfate, passing hydrogen gas through them. So here manganese positive 3 easily reduced by hydrogen to manganese positive 2, so this color will be changed. The color of tube number 1 will be changed to copper of tube number 2, as manganese, as we have explained in details before that, manganese positive 3 is less stable than manganese positive 2, as manganese positive 2 contains D sublevel half filled with electrons. Okay, manganese positive 3, 3D contains only 4 electrons. Okay, so let's have another example. All of the following aqueous solutions of vanadium compounds are colored, except colored means has at least one unpaired electrons. So vanadium 23 argon 18 4s2 and 3d3. So in this case, when the oxidation state of vanadium is positive 5, means losing all the electrons, the 2 from the 4s and 3 electrons from the 3d, it is colorless. So look at this. If we see that vanadium less than oxidation state of positive 5, losing less than 5 electrons, so there must be at least 1 electron in the 3d sublevel, so it is colored. So the question here is the not colored. Here the colored, all of these are colored, but we want the exception, which is colorless. Colorless means the vanadium has its maximum oxidation state, which is positive 5. Here vanadium positive 3, as each chloride ion is negatively charged with 1 charge, so 3 negative and the whole molecule is neutral, so vanadium here has a positive 3 charge, so it is excluded, it is not correct. Here vanadium sulfate has negative 2, and here oxide has also negative 2. The whole molecule is neutral, so there must be positive 4 here. It is not positive 5, so it is colored also. Here vanadium and sulfate negative 2, and vanadium, because the whole molecule is neutral, so it is positive 2 here as oxidation state of vanadium. Okay, so here vanadium, the oxidation state of vanadium here is positive 5, and it is the colorless. Why it is positive 5? Look, this sodium is positive 3, okay, and this oxygen, each one of them charged with negative 2, multiplied by 4 oxygen ions, it is negative 8. Negative 8 positive 3 equals negative 5. The overall charge here is negative 5, so the rest of the molecule must neutralize this negative 5. So vanadium here is positive 5. So it is the correct answer, which is the colorless. There is no electrons either in the S sublevel and the D sublevel. Okay, so the correct answer here is C. Vanadium in this compound positive 5. There is no electrons, so it is colorless. All these are colored except this compound. Okay, another question. So which of the following compounds is used in providing glass with green color? Green color. Okay, cuprous, it is colorless. Here look, 4s1 and 3d10, it loses only the electron of the 4s, so the D sublevel is completely filled with electron. It is colorless. It cannot provide anything with color. It is colorless. Titanium dioxide, each oxide ion here or each oxygen ion here charged with negative 2 multiplied by 2 oxygen ions, so it is negative 4. So here titanium is positive 4. Positive 4 here means it loses the 2 electrons of the 4s and the 2 electrons of the 3d. Look at this. Titanium here, 2 electrons in the 4s and 2 electrons in the 3d, so positive 4 losing all electrons. It is colorless. Here manganese dioxide. Manganese dioxide, it is a very strong agent in the dry cell. It acts as a catalyst in the decomposition process of hydrogen peroxide into water and oxygen. So what is the color of manganese dioxide? It is for you. Manganese dioxide is brown to black. Okay, so it is not green. Here, as I have said to you, as I have explained, it is very important that you know when the chromium is positive 3 oxidation state, its color is green, and this is the correct answer. Okay, let's have another example. Which of the following hydrated ions is violet? Now zinc, we memorized this before. Okay, it is very easy for us. Zinc positive 2 and copper positive 1 colorless because the D sublevel is completely filled with electrons. 30 4s2 and 3d2 loses 2 electrons from the 4s, and the 3d is completely filled with electrons. Here is 29 4s1 and 3d10. It loses only 1 electron from the 4s because it is the sublevel which is farthest from the nucleus, so it is colorless also. Chromium here is green. Okay, so it is not violet. Here vanadium positive 2 is the correct answer, and it is violet color. If it is positive 3, it is blue. You have to memorize all these, but at least you know that chromium positive 3 is green, and here it is green, so it is not violet. These two ions, zinc positive 2 and copper positive 1, is colorless or are colorless. So the correct answer here is vanadium positive 2, which is violet, has a violet color. If it is positive 3, it is blue. Okay? Okay, at this point we finish our session. Thank you all.